Hello. In this video, let's start talking about other loop statements. Um, we already knew or we already work with the while. I want to introduce the do while, something really similar, but the order changed a little bit. I would like to introduce the switch statement. It's a simpler way to do several if dependency case. No pun intended. You will see it later. Um, and I want to talk about a little bit about string formatting and what we can do in all those concepts. So it's really important to know this section and to understand a little bit the functionality or the capabilities pretty much that C# gave us through his syntax and on commands. Let's actually start with the do while. So I'm already located in my projects folder, the C# section. We are going to leave JavaScript aside in this week too. So let's focus only in the C# section. So I have my for loop, my if else, my intro, my object-oriented program. Let's create a new one. .NET new console, and let's call it do while. My do while is there. ls is to list it in a Mac computer. I believe for Windows you actually need to use the dir command to list the content of your directory. So let me actually open code do while. Perfect. So let me explain a little bit about the do while and the while loops and what are the difference. The main difference is where the validation happens. A while loop, the validation happens at the beginning, and a do while, the validation happens at the end. So that means that the while loop can actually stop the statement without executing any code, and the do whiles will always execute at least once the code I have inside. And let me show you that. And let's actually go with the examples we have in the book. So we have a integer called counter equal 1, and let's do the while and we have this one, perfect, while counter is less than 11. We're going to console.write line my counter. Oh, counter. Something really important, we need to increment the counter. Always. Let's keep it really simple. Oh, let me save it, let me open the terminal, and let's do .NET run. There you go, 1 to 10. So we initialize the counter equal 1, and while the counter is less than 11, we are going to grab the content of the counter, and we will continue increasing the counter. Let's actually remove this one, and let's do a string interpolation. Something like this. And I execute again. The number, and then the always with the forwards with the dash that we put at the end. So in order to understand it. Concept that we didn't saw in the last video, but it's important to know, is what happened in this never get met. Like example, the counter will always be 1. So I'm commenting around in order the counter not to be updated. I execute it, and we have an infinite loop. So the program continue printing and printing the number 1 because the counter is actually the value, and continue printing and printing. The only way to get out is with a Control C Control C is to cancel or to close it, and you break out the command and you see it over there. And actually this is a really good pattern. Oh, sorry for that. So it's really important to always have this. Okay, let's say that counter is equal 100. And we need to do this until counter is less than 11. What it's going to do? Nothing at all. Because the counter is bigger, this code doesn't get executed. And let me actually show you the difference with the do while. So, while counter less than 11, let's actually copy and paste this to. So what happened here? What happened is that the validation fails, so it doesn't get executed, but at least the first time get and do it without any validation. And this is the main difference between the do while and the while. And depending on the case, depending on what you want actually to do with your code, you want to actually execute at least once, you can use the do whiles and then start doing the validation and continue forward. So in this case, let's actually start the counter at 1. Execute it, we'll see 1 to 10 to be rendered there. In this case, both of them have the same functionality. Oh, what happened? The counter get updated here, so this actually just gets executed once. Let me console dot write line, and let's put something really simple. And actually let's do it like this. So the first whiles go to execute, counter stays with the value of 10, sorry, of the value 11, so this doesn't get executed anymore. It print my lines, is what I have it here, and then go and print the counter again. Is when the 11 get printed, but because counter is already 11, that means only going to be executed once. And we see the difference here. Something that I put new, the write, remember, is writing the same line without actually jumping, so we are able to print the counter and a dash and stay on the same line. Write line will print everything and jump a line at the end, but this little forward slash end, what it does is to actually jump a line at the beginning. So if we do something like this and run, we will see there are several lines before the trail of stars get printed, because we are telling to jump a line. The backslash n is what it means to jump a new line. It could be handy. As the same, we can have actually the T does do a tab, so what it does is going to be not printed right away, but it's like keeping some space at the beginning, a tab spaces, and those start printing what I need to be printed. Okay, so this is actually the do while on the while. Let me remove this. Let's stay with the do while, and let's make it a little bit more dynamic. Let's say, let's remove the counter. Let's make a string called input. Let's say, well, we can actually start asking. Let's do a console, white line. Do you want me to run inside the loop? Yes. No. Well, let's do a right, no red line. Well, let's do a line. And let's do a console dot readline, and this is going to be saved in my string input. So let's actually put this here. So we're declaring a variable, and then we say that it's going to be printed. Perfect. We can say while input is different as no. Let's continue executing something. Let's do this to specify a little bit. So we're going to execute. Do you want me to run inside the loop? Let's say yes. Okay, inside the loop. Again, let's say yes. And we'll be staying in there until we'll say no and get out. Because the input get changed inside the loop, and then it doesn't get executed anymore. If we do the same in a while, it's going to be very similar. So let's actually use while input here and copy this too, and let's comment it out, the do while. This is going to be exactly the same. Yes, no, and get out. So until we specify the no in the read line, we don't need to parse it because it's already string whenever we read from the console. So this is going to be executed once and once. But the difference here is going to be this one. If we specify no at the beginning, the while loop will actually break it. But the do while, it doesn't matter that we specify no, it's going to be inside and it's going to ask us again. So it doesn't matter at the beginning. This is the case and the difference between the do and the while. Something that we need to remember, something that we actually need to see to understand. And when and when not, we need to do it to use it. Okay, let's continue now with the, let's maintain the do while. Let's actually maintain the string inside. And didn't like it, this one, oh, because it doesn't exist. So let's declare the string input without any value, which is going to be deleted. Perfect. And let's use the letter grade assignment, something similar that we already did, and I believe they will have something in there similar to this. So let's see, this is a grade letter converter. And then we'll say something like put a number between 0 to 100 and it will be converted to letter grade. And we can say X. Let's do another one. Console.writeLine. Let's write our escape character. Type X to exit. Oh, pretty cool. I can show you something else. So what about if I want to print these double quotes in my prompt? What teacher perceives that I'm finishing my line here, and then I have this extra or aside syntax error. So in order to wait to print actually a double quote and don't get it like a delimiter for the text, I just put the backslash in there. So C# will not actually to print this and get out. So let me use, without saving it, only this part. Okay, just give me that the input was declared but never used. Doesn't matter. Okay, I just want to see it, that I can actually print the double quote in the console. So it's what I wanted. Perfect. While input is not X. So let's do write number grade. Input going to be read line. If let's do a really quick validation. If input is not n, and we can actually specify let's say integer dot parse input. There is something really complex right now, and I will explain what it's actually doing. And let's use for now console.write line is valid. So what I'm doing is a little bit of complex validation, but I'm doing it in one line. And I want to show you whenever I put the valid number grade, it's going to be printing that it is actually valid. So let me execute. Number grade 20 is valid, 50 valid, 101 is not valid, so it doesn't print anything. -3 is not valid, so it's not print anything there. And X is we have it on handle. Done that quick. Okay, yes, ignore. Oh wait, we don't have it there. So we have the X. Okay, yes, perfect. Because X is for exit. In this case, any other value that we know, we want to break the program. That's actually what is happening now. Okay. So what it's doing here, and what I'm actually doing with those parentheses and with those ampersands, what it does there? Well, this is a logical operator. So we know that inside the if statement, inside the while statement or the whiles, this and this needs to be true in order to execute whatever is inside the different curly brackets. So we're saying that the input should not be an X. This is really important. The input should not be an X. If the input not an X, then we're saying and. So you need to actually take this value and whatever, and then open a parenthesis. So this needs to be validated to true. But here I have another and inside, but because I have it in parentheses. So the order of the validation is going to be like this. And hear me out. It's a little bit complex to understand, but just to see it. The predecessor of the high ancestor is actually going to be execute whatever is inside the parentheses. It's how pretty much any programming language does. So the if statement have a parenthesis, so it's going to execute whatever is inside. So let's actually, inside the if is going to be executed this section. But here we have another parenthesis. So it's going to execute this section too. So in this case, actually, let me save it, let me try to run it. I don't know if it's going to work like that. Oh, it is. Perfect. I just separated a little bit to understand what is happening. So the first thing I'm going to do is going to parse my input and going to check if that input is greater than 0. Is the input greater than 0 and is less or greater than 100 is what we are actually doing. Let's execute over here and it's working. Perfect. After this complete statement is true, it's going to validate that the input without parsing, really important, this is get parsed, this is not getting parsed, it's not an X. It's not an X, and if have these two validations in there, it will proceed to show me that actually is valid. It's pretty much what it's doing. So let me just return the spaces where they are. Perfect, and leave it like that. So now that we know that it's parsed, let me check. Let me just remove this too, just to edit that, and let's do the switch statement, and let me explain what actually switch does. Let's have an integer rate equal pretty much this. We know that we passed the validation, and then I save in the integer section as a grade. Now, because an integer, let's actually do console dot write line And let me show you a string interpolation. Let's see what is showing whenever that grade it get divided by 10. Let's see what it gave us. So if I put 10, it should show me 1. If I put 40, it should me 4. 100 should me 10. Perfect. 90 should me 9. What will happen if I put 95? It still show me 9. What happens if I put an 89? It still show me an 8. 90, perfect. And 99, an 8. So what is doing here? Where is my float numbers? Well, they are not there. And they are not there because the variable where it actually came is a integer. In this grade should be a decimal, for example. Let me get out and execute again. By the way, I get out with Ctrl C cancel. It's a way just to break the project. If I do 90, and what about 95? Now it's showing 9.5 because my input is a decimal declared. But because now we are working with integers, we know that this little hack, what it does, just gives us like the value of the sense. That is actually what we want. So let me get out. Now that this actually works, let's do the switch statement. And the switch statement is going to be doing is, depending on something that has happened, you will execute something, and depending the output, you will react. Is what we are doing with the switch statement. So in the switch statement, we're going to put the grade divided by 10. So it's an integer, and we are parsing it as an integer. Perfect. So it's going to be divided by 10. And we'll say if case 10 and case 9, we will see console.writeLine A. Break. Pretty important just to get out. Case 8. Is going to be a B. That's actually case 7 is going to be a C. Case 6 is going to be an D, and the default behavior is going to be an F. So the rest pretty much is an F. And before explaining it, let me actually just execute it. Let me delete this part. So if I put a 100, it's an A. If I put a 75, it's a C. If I put a 60, it's a D, but a 59 is an F. So we have our converter over here doing a switch statement. And it's pretty much what we're doing. So the switch, again, what it does, execute this, and it will validate the output with different cases. In case of 10 and case of 9, this is going to be executed. So we are telling them if it's a 10 or it's a 9, just write an A. It's really important to break it. If not, it's going to be just pretty much continuing doing the rest. is when we say, okay, well, this is case an 8, just do this section. In case of 7, just do this section, and go on, go on. When we pretty much finish all the possibilities, we have the default statement. The default, what it does is, well, if nothing of this is actually in there, just do this section over here. And that's it. If we remember the one we did with the if statement, we have if this equals this, then this. If this equals this, print this. If this equals this, print this. So we repeat the code several times in order to achieve the same functionality that we can have doing with a switch statement. And it's going to be depending the case and depending the values that we are going to see. So I like it. I believe this is what we want to do. So I will require for the video lab actually to give me this code without changes, pretty much just like that. At the beginning, please just add your names as comments, something like that, and with the pretty much the header of the project with the new information in there. Okay. So we can actually leave it like this. Let me get out. And let's do a new one. Really simple. New console format. And I'll show you a little bit how to format a specific code. Whoa. Code format. Terminal, new terminal. I open my CS program. And let me actually remove this. Let me show you something really cool about the formatting a specific string, what it does, and how it can actually help us a lot in different functionality. So let's do the do while or the while loop. Counter less than 11. Let's do integer counter equal 1 and console dot red line counter. Of course, counter plus plus. Actually, I believe we can do the counter plus plus over here. Let's execute .NET run. Yes, and it's working. And probably you will say, wait, what's happening here? We are increasing the counter in the same property that where we are executing. Remember, then we have the plus plus sign after the fact, and we are assigning this value to something, in this case the console write line. The value that is going to be assigned is going to be the previous value. So the first loop, counter is equal 1. That's why it's actually when we print it, counter is going to be, the write line is going to be assigned to 1, but my counter is already 2, because we increase it. So the second iteration, the counter is already 2, and that actually works. We can actually save a line of code doing something like this, just to simplify stuff. Okay, pretty cool. But we can have different formatting styles. We can have something like, let's do the string interpolation. And let's put this counter inside curly bracket. For now it's going to be exactly the same. Perfect. But let me do it, comma 10. Inside the string interpolation, and let's see what happens. Our numbers get printed a little bit to the right. If we increase this to 20 and execute again, it's going to be printed further to the right. Let me actually increase this to see it. So this didn't have any value. This have the value 10 and this have the value 20. What is actually happening over here? We are assigning how many spaces the output is going to have. So when we doesn't specify this, we are declaring just get printed as it is. But when we specify number, those are the spaces that are going to be assigned. So we assigned here 10 spaces in the second iteration. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from my beginning to here are 10 spaces. That's why the 0 for the 10, you get a line with those numbers, because a right alignment in a 10 spaces group. What happened when we execute it as 1 and we have a number that uses more than once? It's going to be overflowed. Let me just get my terminal down. Let's do country equal 100, and when is, let's do 111. Less than 1000, and counter, let's do equal to something like this. If we assign 4, ever this 3 is going to be together to the right. If we assign 5, everything is going to be moved a little bit to the right, but if we assign 3, it will have this specific behavior, because it get overflow in those 3 and actually just get printed as it is. Something that we need to just take care. So let me just go back to the counter plus plus and the first elements. Perfect. So in order to verify or see that a little bit clearer, let's do a console.write and let's print a little star. Let's change this right line to right and let's print the star again. And after we get from this and this one, the last star will have a jump character. Perfect. Run, and we can see it clearly. So this is going to be printed, then take 10 spaces to print the number, and then at the end is going to print another star. This is a way like to have some kind of table layout, probably like a column, and mix it. So this is a way actually just to print it. If we want to have left assignment, we'll just put the negative number in there. So when we do the negative number, it is still assigned the same spaces, but it's just do the same align, left align. When it's not, it's doing the right alignment. It's the default behavior. If we actually remove this number and we see it like that, we'll see each number you just grab it in the little stars. So we can see that comma something are the spaces that we're defining to that specific number to have. And not only for numbers, this can be strings, can be another type of variables or values, and it's still going to be working. At the end, there's something extra that we can format. are really cool. Let's say that this number actually are a currency. So in order to print the currency, we need to say something like this number dot 00, for example. So we are pretty much printing it like that, right? We have some dependencies, something there. But to have a better way, at the end of the variable or the value, the sizing, we can actually specify a column over here and a C. The C is when telling them, okay, it's a string format, and this string format is a currency, and this is going to give you, it's going to change those integers to currency as the way that it's supposed to be. Pretty cool. Some part of the variables or the names that we can actually have. Sorry. And it's not the only one, and we can actually specify different kind of formatting that we wanted. The most common one is actually for date time. So for example, let's print it like that, and let's have a console.writeLine, and let's do date time now. This is what it's going to be doing. You just give me the current date in day and hour. Perfect. But we can actually specify something like this, and we can actually do a string interpolation, and we can say that we want this to be formatted as date. So now you give me the date section, or just give me the time, and just give me the time section whenever I'm running or creating this program. So this is just a way to actually format the value and do something specific that we want. Another way could be to have like let's say string text equal I am a super cool text. I don't know, something like that. You know what? No, let's do text with time. Today is curly bracket. Oh. Okay. Let me actually get at this. And I will show you a website I want to give you. So this string will have a specific format. So we can actually create our own format, and we can say something with the string interpolation. I'll say today is, we can have the date now, that time, sorry, that now format date, the time is an informal time. Oh yeah, I cannot do string interpolation here. What I need to do, something like this, and I do comma. This is going to be 0. This is going to be 0. So whenever we wasn't able to do a string interpolation like now, we can specify the text, still specify the curly brackets, and assign a specific number. And that number is going to be the order of the variable that is going to be assigned to here. So from here, I will give it the date, time now. The thing with C# and other programming language is that everything starts in a 0, not in 1. So this is going to be assigned wherever we have a 0 in there. If we do a console.writeLine text with time, we have the counter with a number, and today is today, and the time is this time. We have a specific string, a specific format with specific text that we can actually use for a later program. So to solve something that we want. This is not in the book, the string format section, but I will give you the official documentation where you can actually read a little bit to understand it, to get it. So for this lab, I actually will require 2 programs. I will require this little program, just at the end, and my name is, let's do something like this, 1, let's do a string, my name, Slim Shade, so no, Rodolfo Roman, and we can say comma my name. So today is this date, the time is this time, and my name is Rodolfo Roman. So this is 0, this is number 1, so this is going to assign 2 zeros, this is going to be assigned where we have 1. So for this video lab, give me the one with your name in here at the end, and give me the other one that we already saw for the do while with the switch statement. And that's it. Hope everybody liked this week video. See you in the next one. Happy coding.